And I'm Rob Bertini, and I want to welcome you all to our transportation seminar. And I will just very quickly introduce Professor Kate Hunter-Zaworski from Oregon State University. And it's all yours, Kate. Thank you very much for coming.
Thank you. I'm delighted to be here, come to visit Portland State University and have an opportunity to tell you a little bit about the National Center for Accessible Transportation. We're located currently in Apperson Hall, but Apperson Hall is going to be remade in the next few years, so to keep the shell and redo the inside. And I know Steve was a student there. They're going to actually make the floors level finally. We are currently housed there, but we're likely to be moving next door to Owen as it's vacated by the electrical engineers who move into a new building. And just to give you a little background about myself, I've been a resident of Corvallis off and on since 1983. And I work in the area of both transportation and also rehabilitation engineering. I combined the two and brought them together in development of the National Center for Accessible Transportation, where we try to remove barriers to transportation for people with disabilities. And the presentation this afternoon, is going to tell you a little bit about a number of our projects. And if there's time at the end, I will show you some fun work that we've just finished on bus rapid transit and securement systems. Our mission for our center is for research and development towards improving access of people with disabilities to public transportation, and primarily to intercity public transportation. And our goal is to make travel seamless, safe, and dignified for all. And I'd like to emphasize the importance of the dignity. And we have a number of projects that we're looking at, primarily access to small, large passenger aircraft, buses, trains, somewhat of a focus on aircraft, and looking at getting people on and off those aircraft in a safe manner, and also to trying to improve the accessibility of the onboard lavatories. In addition to that, we have projects related to real-time passenger information systems in the terminals at the point of departure from a terminal, on board the vehicles, and also prior to taking a trip, through making sure that online reservation systems are accessible to people who use assistive technologies on their computer. And lastly, a project which takes a lot of the information that we learned from our earlier research projects is developing passenger assistance training for people for airlines, rail, and over-the-road buses. So I'll give you a little bit of an update about some of our projects. And the current one is, one of the challenges we have is that when a person boards an aircraft, they transfer to a special seat. And you can see this is a collaborator, Uwe Rutenberg from Ottawa, Canada, sitting in a transfer chair. And he's actually on a Horizon Airline I think that's a Dash 8. And the challenge is, you can see that he's trying to do a transfer in a very, very confined space. Well, when we wrote the initial proposal, we discovered that the body of knowledge associated with transfers for people to and from wheelchairs is actually very thin. Surprisingly so when you consider how many times a day a person undertakes a transfer. And so we're embarking on a major biomechanics study where we're really looking at what happens in the transfers. What are the loads that are imposed on the people providing the transfers, as well as our dummy, whose name is Ted. We didn't select orange, by the way. He is a beaver. He loves orange and black, but that was the way he came. And he looks really bad in green. So what we've done is we have Ted is instrumented. You have force plates on the floor. We have a number of elements of instrumentation. And through this data acquisition system, we're able to determine what exactly is going on, which is a good thing to know because we're working on redesigning of the transfer chair. We're starting to look at elements associated with the aircraft seat. And what's amazing is I've actually wanted to do this work for about 15 years. But the data acquisition system that we're using didn't even exist. And so now that we have these new tools, we're able to do this study. So you saw that the people providing assistance have little white balls There's actually 8 cameras that pick up that information, and then it's massaged through some software, and we're able to determine what the joint angles are, what the angular velocities are, the peak forces and torques at different levels of the spine, and this is a very important piece of information, and then to use that information to develop a predictor for injury, because what we're trying to do is minimize the injury potential for people providing assistance, and so that the person being transfers in a much more dignified manner. Well, we have a similar problem with accessible lavatories, or I should probably say inaccessible lavatories. As probably most of you have traveled, most of you have flown, you'll know that space on an aircraft is at a premium. And one of our challenge is to try to make sure that the lavatories are more accessible than they currently are. Now, we're never going to have a 5-foot or a 7-foot lavatory on board an aircraft. I'm sorry, but that just isn't going to happen. But there are ways to tweak the design to make it more accessible. At the same time, one of the challenges that we're facing is the population in general is becoming more obese. And so we're trying to economize on our space, and yet we're also having to deal with a population that is much larger than it used to be. This is, again, our famous model, Ted. He gets to go on lots of trips. And this trip was up to an aircraft manufacturer who has a model lavatory that we played in and did a lot of analysis for. And so we spent time trying to figure out ways that we could improve access on a currently accessible lavatory that's used on twin-aisle aircraft. And one of the questions was, could we save some dimensions on this aircraft? We saved some dimensions on the lavatory. We saved weight. Every pound of weight is $1.5 million. So we were able to shave off a few inches. We were able to save the aircraft manufacturer some weight, and they love us. They just don't give us the money, though. And again, we have doing transfers in confined spaces. Now, when I showed you the biomechanics slide earlier, it was a 2-person dependent transfer. That is what happens when you're transferring from an onboard chair to the aircraft seat. A different type of chair is used when you're moving from your aircraft seat to the lavatory. It's called an onboard chair. It's one that folds. And you do a 2-person transfer from the aircraft seat to the chair. The chair is taken to the lavatory. But at the lavatory, a flight attendant is not permitted to enter the lavatory. So at this point in the process, it becomes a dependent transfer with one individual, and this individual that is providing the transfer is the personal care attendant. It is not any flight attendant. They are not permitted to actually even enter the lavatory. So we've come from a 2-person transfer to a single-person dependent transfer, and again in a very confined space, and we're again doing similar biomechanics analysis to look at ways that we can optimize the spatial layout of that lavatory, and also at the same time evaluate the injury potential both to the person being transferred as well as the person providing assistance. In addition to the biomechanics research that we're currently undertaking, we have 2 major survey projects. We're just completing a survey for the airports. We sent out 500 surveys to commercial service airports in the United States, and we have an almost 60% return rate, which is very unusual. Gathering information about airports. Now, when we put this survey together, we had an explicit goal, which was to determine the level of accessibility in the airports. Our sort of underlying dream and wish was that by some of the questions we asked, people would start to ask questions about accessibility for their airports. And indeed, that is what's happened. And so we gave the people responding to the questionnaire phone numbers to contact us. And it's been really fun because we've had some great questions and great dialogues. People are starting to understand that there's really much more to accessibility than they first thought. And so the airports now, having had this questionnaire, are saying, oh, you know, there's so much more we could do. And we asked about, do you have a person assigned who's responsible for making your airport accessible? Well, most of the airports hadn't even thought of doing that. A number of airports do that, and they said, you know, that's such a great idea. So our survey became a catalyst, which is exactly what we hoped for, but it wasn't exactly explicit in our intent. So we're just going through and doing the analysis of this right now. At the same time, we want to know why people travel, what they've encountered when they travel. Again, people with disabilities. We also want to know why people don't travel. There's a significant number of people with disabilities that don't think they could travel. And we want to know what those perceptions are, and we're currently crafting that particular instrument. The other piece to this survey that's really fascinating is the fact that in the realm of disability research, there's always some bias. And so we're actually using a fairly innovative survey sampling technology or system to try to reduce the bias and also get results that are statistically significant. So just an analysis, our airport survey is complete. We're just doing the data analysis. We're developing our instrument for the traveler survey, and we're also playing with some sampling methodologies that are pretty unique to working in the disability community. And we've also have 2 opportunities for additional questions. One is through the Transportation Security Administration. They are sending out a questionnaire in April or May, and we've been asked to submit 2 questions for that. And then we're also piggybacking on a survey that was done by the Bureau of Labor Statistics. So we have essentially research projects, and then from the research projects we move into what we call development projects. And one of our main activities are a number of design projects related to boarding technologies. And if you think about the boarding piece, there's several areas that we want to talk about. We want to talk about the transition from the terminal to the vehicle, and sometimes that is not always as straightforward as one might think, and it's particularly in the use of an aisle chair. One of the problems that we have is that if you travel throughout North America, there is a tremendous variation in accessibility, in what people understand to be accessible, people's expectations. And so one of the things that we keep hearing about are frustrations from travelers. They leave Portland, and Portland and Eugene are some of the most accessible airports in the country, and they go elsewhere. And they find that they're not treated with the same respect or dignity, and they get really frustrated at this lack of consistency. So one of our goals is to try to have a better understanding, more science behind this, so that people have a more consistent travel experience. And I'm trying not to label airports that are naughty, because that's always not a good thing to do. So there are some airports that are less than wonderful when it comes to access. So we are looking at issues of transition. We're looking at development, redevelopment of what's called the aisle chair or the boarding chair. And from this will come an enhanced code of practice that will be used. The other issue that we have in this realm is that the airport accessibility is determined under the guidelines for the Americans with Disabilities Act. The aircraft itself is under the Air Carrier Access Act. And there's tremendous inconsistencies in who has jurisdiction there, those transitions, and that's part of the reason that we're in the world that we are when it comes to access. So there's a political issue as well as a technology issue. I showed 2 basic types of tarmac-based technologies. These are used in airports, small regional airports that don't have jetways. One is what we would call exclusive. It's this one. This is used in a lot of areas. It's a device, that would be a nice word, where a person comes out, only the person with disability uses that. In other words, it's exclusive to that person with disabilities. It comes up by the aircraft and they board. It's just a hoist mechanism. A number of the regional carriers in the Pacific Northwest, they don't like the idea of a mechanical contraption interfacing with their aircraft. And so this device is one that they really, really didn't want to have to use. So they looked at some other solutions. This particular device Anybody have an idea what this might have mean in its other life? Oh, I wish. It comes from Southern Oregon. Cattle? Seriously. Low tech? Excellent. It actually, they have, they have roofs so you can keep the weather. This is a very simple device. Oregon product. And you know what else? What's special about this device? Everybody uses it. It's universal design. And for people who are elderly, who have trouble with stairs, it's not only for people who use wheelchairs and transfer chairs. People who have trouble with stairs use this device. Everybody uses it. It's inclusive. And it's simple, very simple, and it's not a mechanical system. It doesn't have any electronic parts. You just roll it up to the side of the aircraft. So it has a lot of features. And this is used a lot in Oregon and many other parts of the country. So I don't get to toot the horn of Oregon companies very often, but this is one. And another example of Oregon innovation and technology, these are terminal-based technologies. Yes, sir?
In that last slide, the angle of the ramp there, how, I think the ADA is like an inch a foot, is that right?
112 at maximum.
That looks like it might be a little bit of a stronger slope than that. I mean, is it, when thinking about these types of things, I mean, how much of a disadvantage is it as you start to get over that, and how much of an advantage, over the inch a foot thing, and how much of an advantage is it, even the smaller decreases in that?
Okay, that's just, we're going to segue away a little bit on the ramp angle. A 1 in 12 slope is actually really hard to propel oneself up independently. Okay, and generally, when I work with architects and designers, I try to go 1 in 16 or 1 in 20. We have, when our physical plant doesn't believe me, we have a couple of ramps on campus that are 1 in 12. So I lend them a wheelchair, and they quickly understand why they want to be 1 in 16 or 1 in 20. Because if you're on a 1 in 12 ramp and you happen to be in a manual chair, I have one quirky chair that's always great for demonstrating things. They'll have the perception of rolling over backwards. So,
like eyeballing that, is that like an inch a foot, or is that?
I don't know. I think it's less than 1 inch a foot. And also a person on this is usually assisted.
Oh, so an inch a foot is pretty steep.
It's very steep. Yeah, yeah. And that's why I say if you are in a chair and you have a long ramp that's 1 in 12, you need to be in very good physical shape. This an assistance provided on here. And a person using this would be, unless they're ambulatory, they would be in an aisle chair and provided assistance. So they're not doing it independently. Okay. Very good question and observation.
I guess one question I have is someone as a 3-year-old, it seems like if everybody. One question I would have, I mean, it looks like a great inclusive device, but as someone who has a 3-year-old, it seems like you have a, for smaller kids and stuff, it's really open for kids to go off the edge of it.
It's not actually.
It's not?
No. I don't think you can see it, but this is raised. This is about 4 inches on the edge here, and then you use the double, and it has 2 sets of handrails. Okay, and I doubt that you're going to have a 3-year-old unescorted and running up and down here by themselves. Okay, but let me give you some perspective.
No comment.
If you didn't use this, you've got your 3-year-old going up these stairs.
Well, I don't think it's, I think it'd be easy. I mean, on decks, we have code for decks in the city. You could easily build the bottom of that to a standard that wouldn't have kids falling through it.
Oh, sure, sure. And this, I say, was an early prototype. It's out of Central Point, Oregon, and serves its intent well. It's made a nice maturity from cattle to people. Okay. Also, another area that we are challenged with access to are those airports that may or may not have existing jetways, or if they have jetways, they're not built to accommodate the lower regional jets. And these two photos come from Eugene, Oregon. This is a prototype that they put together for the regional jets, and it generally serves Horizon. And then also we have a adaptation to the existing jetway that is used by United Airlines as well. Now, one of the things that we're challenged with on our projects, and I'll talk a little bit about, are these transition zones here. So the jetway is kind of one of those areas that, well, it's not really part of the airport, so it doesn't really fall under the Americans with Disabilities Act. And it's not part of the aircraft, so it doesn't fall necessarily under the Air Carrier Access Act. So if you use many of the jetways in this country, you'll know that they're steep, they've got sharp transitions. It's one of those areas that kind of falls through the cracks and can cause many difficulties and challenges. So we're trying to come up with some better guidelines and specifications for jetways in general as well. So we're looking at a number of the existing boarding technologies. We're developing improved designs, and we're doing this through a number of student design projects, senior mechanical engineering, capstone designs. And we are developing recommendations for a code of practice for boarding procedures and technologies. There are a couple of guidelines that the Access Board has. They were developed in 1989. We're revisiting all of those and coming up with more up-to-date guidelines. Oops, let's go back. Here we go. Do we have any mechanical engineers? Okay. One of the tools that we use for design that we teach about at Oregon State University and we've used in the area of design for people with disabilities for a very long time, it used to be called Quality Functional Deployment System, and this is now migrated and become what's called a house and quality. It's a very vigorous approach to design, where we have a wide stakeholder base. So in this case, this is an example for the aisle chair. The number of stakeholders, I think, are 25. And the number of requirements for our stakeholders is approaching 42. And then what we do is we define our stakeholders, we define the number of issues associated with those. We take existing technologies and we evaluate each of them, or what we would call benchmark them, and look at the plus and minuses and whether there is an existing design that we can modify or whether we have to go back to the drawing board and start all over again. It's a very powerful tool, and it forces you to ask a lot of questions early on in the design process and really structures the design process. So even though the time initially is longer, the time to prototype development and all of that is actually in the long run much shorter. So moving along, a couple of other projects that we look at are real-time communication. So how many people here have missed a plane because they didn't know the gate changed? Yeah. How many times have you transferred from one aircraft to another, you get there, they're boarding, and you have no idea what row they're boarding? That's pretty simple, straightforward information, yes. So our particular project is looking at real-time information for travelers at the point of leaving a terminal, so that gate information, that type of information, as well as onboard information, particularly that pertains to safety and security. And looking at different receivers for that information, but also people with sensory and cognitive deficits. And this becomes very important as we think about a population that is aging and the importance of looking at ways that we can provide information to them. So travelers need real-time information. They need to know what's happening. Is their plane 4 hours late? Are they boarding? Are there necessary paging that they need? What's happening when it comes to safety briefings and things like that? Well, generally what you find is that most information is given only in one media, which is fine for most of the population, but it does have problems for travelers who might have sensory cognitive deficits, or people who are distracted and not paying attention, or in general for most of us who travel that can't hear anything over a public address system because of all the background noise. So we are looking at a number of new technologies that will help that. Now, this isn't exactly rocket science, and again, Portland Airport is one of the first in the country to develop what's called a visual paging system. Most of you have seen this. And it's really nothing unusual in the fact that it has a way to visually give out what's being said over the public address system. very, very useful. And then again, I apologize for the quality of these pictures. There's one other thing here, and you can't see it on this, that's also pretty unusual about Portland Airport. Have any of you visited Portland's website, PDX website? You visited PDX. So you want to take a guess at what's unusual about PDX website? What's that? It's hard to navigate. Ooh. Okay, well, there is something that's very unusual. How many of you have dogs? Okay. None of you have service animals, I don't believe. Okay. Portland has notice on their sign on where you could take your service animal for relief. And you probably think, oh, I've done a presentation like this around the country, and you know what? There's a lot of airports now looking at places to have service animal. And you know who's driving it? TSA and INS. They said, oh, this would be so great because we wouldn't have to leave the airport for our drug dogs. Yes. So that's another example of universal design. You might think we're having an area just for service animals. In fact, we're benefiting all the airport, and they're very appreciative of that as well. Another example of a real-time information system, and again, it's in this case, all you're doing is adding 2 extra pieces of information. Very trivial, in fact. And that is, well, telling you where you're going. That always helps. But the other one is telling you what rows are boarding. You know, that's one simple piece of information. This particular project, the Visual Boarding Information Project, was conducted at Ottawa, Ontario, and also Toronto, Ontario. And initially, the funding was for people with disabilities. Well, when they did their survey, they sort of surveyed everybody, and everybody liked having that information. So even though it was focused on giving more information for people with disabilities, in fact, the traveling public thought it was great. And then when they took it away, they were really upset. Like, well, how come we don't have that information anymore? Well, it was just a demonstration project. And so I think it's coming back. So again, another example of where we've designed, particularly for people with disabilities, and we're actually designing for everybody. And so we have a concept. One of our challenges is that in the area of communication and information, the world is changing very, very quickly. And what's happening right now is most of our airports are becoming wireless in one form or another. There are some security issues that have to be worked out, but generally there are some sort of wireless infrastructure that is either in place or under consideration for almost all airports. And the next issue is, how is that information going to be received? Well, it could be on your cell phone, your personal digital assistants, you might have your computer, you might have BlackBerry, you might have who knows what type of device in the future that will give you this type of information. And it's particularly important, again, for people with disabilities who happen to use variants of these technologies for information. I was at a meeting in Japan not too long ago, and one of the people was saying about the fact that they have cell phones that also have a GPS system on them, but they have cell phones with cameras. And you think, well, why would a person who's blind want a cell phone with a camera? So they can take a picture of where they are when they're lost, transmit it back, and people can figure out where they are and then give them correct orientation and mobility information to set them on their way. Yeah, I was sort of like, oh, well, that makes sense. Yes, sir.
How expensive do you think this type of system with the wireless data is? And I mean, what I'm thinking, and I'm probably way outside the box here, is outside of airports and streets. You know, like downtown Portland, where there's really good Wi-Fi access, and a lot of construction zones that make it difficult for people with mobility issues to navigate, that this could be a really great solution, especially when you start to have a lot more GPS out there, for helping people know, hey, 2 blocks ahead, you're going to be forced off the sidewalk, you might want to, move in a different way.
Well, actually, Japan has quite a lot of instrumentation. I think they use BlackBerry, though, as their mode of transmission. San Francisco has implementations. Let me tell you about a project that this is sort of off what we're talking about but it isn't. Have you been to Union Station? Do you go through Union Station in Portland? Have any of you noticed anything different in Union Station in the last few months? No. Union Station has a system called talking signs. This was developed by the Smith-Kettlewell Research Center in San Francisco, and it's a system where you have an infrared receiver, and it was initially designed for negotiating a couple of really challenging BART stations where a person who's blind will go through, and this receiver would give them information and say which door you're approaching and help them to align and orient themselves. It's a technology that's now international, and it is used in ways that are almost beyond imagination. In San Francisco, they have it tied into the street system, so a pedestrian coming along can see where they're at, which street they're crossing, and we're trying to, I'm not sure if it's implemented and out of the lab, where it ties in with the signal, so they also know when it's a walk signal as well. Union Station in Portland has orientation information, so for a traveler who's blind, using the system, they can negotiate their way through Union Station. And Portland, I think, I'd have to talk to Bill Close, and you've had him through here a few times, but I'd have to chat with Bill to find out where Portland as a city is on this. Portland, again, is one of the cities that's very accessible for pedestrians with disabilities. And I know we've talked about it, but I'm not sure it's out there yet. So it's coming, and you know, one of the first places it will be is right here. I love coming to Portland because Portland is a great city for people with disabilities. We have a seamless, accessible transportation infrastructure that most of the country dreams about and doesn't even know they could do. So it's really wonderful. Okay, last part of one of our projects is we have learned a lot of information from our biomechanics projects. We are looking at what passenger assistance training there is. Now, passenger assistance training in an urban bus environment means getting somebody on a bus and tying them down and securing them. Passenger assistance training in this context is helping people learn how to do a transfer from a mobility aid to a transfer chair or an aisle chair to an aircraft seat. It's doing that transfer piece. This is an area that is not well developed, not well understood, and particularly an area where you see the most claims in terms of the people providing assistance as well as people with disabilities. And so what we're doing is using the information out of the biomechanics project, working with educators that work with training material, particularly for airlines, and developing very focused passenger assistance training. And we're partnering with a number of airlines, actually with Portland International, the contractors there that provide that training to move forward. What are we hoping to achieve with our Rehab Engineering Center? We wanted statistically validated survey results. Now, that's important, the word statistically validated. For students, your eyes can glaze over. But just having qualitative information is not good enough. We have to be able to tell people this is what's happening. And also a targeted training for transport. What are the best ways to provide assistance? We're also looking at ways to improve the safety and dignity of travelers with disabilities, and we feel that that's really important, and also to preserve the integrity of those people who are providing assistance. It's a two-way street. Want to reduce the number of complaints. We want to increase the number of people with disabilities who want to travel, to make it more appealing and know that they can do it. And there's a number of ways that we're exploring that we can do that. And we would like to have, under the Air Carrier Access Act, a little bit more substantive regulatory issues that help them. And this is just the acknowledgement I'm funded by the U.S. Department of Education. What I'd like to do for the second part of our presentation is switch gears a little bit and talk about a couple of our other projects, which are also really fun. We've just completed a project that was funded by the National Academies for bus rapid transit, and we, some of you know that, but know that Oregon State's been working in the area of wheelchair securement for about 15, 20 years. And one of the issues that we have struggled with over the years is people really don't understand what's going on a transit vehicle, what the vehicle dynamics are. And so we've just completed a project that was a lot of fun, looking at looking at the vehicle accelerations as an underlying for really understanding what we need to do in terms of securement. The ADA, in terms of securement, says a 20G crash. Oh yeah, that might be true for a vehicle, a car, or a paratransit vehicle. There's no way you're going to get 20 Gs out of a transit vehicle. I'm sorry, but it's just not going to work. The other thing that we're looking at is rear facing. And there's some advantages to this from a safety, from a dignity perspective. And it has been used in Europe, it's been used in Canada. AC Transit in Oakland does it, but it's not well understood. And we think that it provides opportunities for much more seamless and dignified travel in the future. So we instrumented our buses in a number of places. We did it both in Canada and in Eugene. And we went out and we looked at what are the accelerations that you're going to see on turns. And you can see that the maximum we got was about 0.4 G. We'd actually done a seat of the pants study in this area 15 years ago and got exactly the same data, but it wasn't exactly scientifically based. So it was sort of a seat of the pants study. But now we have the scientific data that backs up what we had as hunches way back when. And again, stops. You're looking at 0.15 G. So why do you design securement systems for 20 Gs when you're really seeing very, very, very low accelerations in normal driving conditions? And so in general, we were seeing about a 0.2 G power. We're seeing that the turns maybe 0.4 G. We had a stop that was 0.4 G. These are heavy, massive vehicles. You're just not going to see 20 Gs. They're not Ferraris, I'm sorry. They really don't go that way. So then we went on and we played and we did 6 different types of buses, low floor, high floor, articulated buses, double deckers, and instrumented those as well, both in Eugene and in BC. And we had an opportunity to partner with BC Transit and Transport Canada. And we wanted to see, okay, what's the maximum accelerations we can get without damaging the vehicles? And what happened to the mobility aids that were on board. So we partnered, and this was kind of boy time. I don't want to be sexist or anything, but they had fun, okay? So they ran these buses around the test tracks. They started, they go around, they do things, whoops, go back. And they run it through curves, stops, severe turns, all sorts of things. And yes, the cones had a really high mortality rate. And there's a fair amount of rubber that's left on the test track, and there were a couple of engines that really had a tough time. And the drivers had a ball, and so did all the guys riding it too. So it was boy time. They had fun. And we really did have a lot of fun on this project. So we instrumented the vehicles, and they went out and tested them. And you can see we're still really low Gs, less than 1 G, really. And then we also wanted to see what happened to mobility aids. So poor Ted, our guy here, he rode the bus in Victoria, and you can't hear the audio very well, but just take a look at what happens to a manual wheelchair in a turn. And what I want you to take away from this is a realization that we have to do something, okay? We can't just have a chair sitting there unsecured. But you can start to see that he's rocking and he's rolling a little bit, and come on. Uh-oh. Yeah, it's tough to be a crash test dummy. It really is. So we also wanted to see what happened during stops. And there's a couple of really interesting phenomena that came up in this part of the study. We first noticed it when we were running the buses in Eugene, and it became much more pronounced when we ran the buses up in Canada on the extreme tribe. We have a rebound effect. And one of the other things I want to show you is this is where you can see the sort of the severe stops coming here, and then this. Anybody know what this is? And it was very consistent. You sort of have a ringing, and we discovered that the buses have a natural frequency. And so then they went and tested what the frequency was as well, and that was very funny. But there's some things happened here that people hadn't expected. One is the ringing and the rebound. And some of this has to do with the suspension of the bus, the rocking back and forth, and the impact that has. Okay, Mobility aids, three-wheeled scooters. For many of us, that's been a challenge for almost 20 years. Okay, again, moving along, it's going down the test track, and you can't hear my husband's voice narrating what's going on. You go around a turn. You can see the back wheel is up. Yep. If you ever get bored, we have hours and hours of this footage. Not, this is just, okay. See, it's tough to be a crash test. Now, the next one I want to show you is that little pink wheelchair. Anybody have a clue how much this wheelchair weighs empty? It's a power chair. Exactly. Absolutely right on. Yes. 250 pounds. And Ted weighs 170 pounds. So do the math. Okay? So typically this chair didn't go very far. Okay, just stood there. And didn't do very much with turns. It's pretty... But one of the things that we did see is, again, a rebound. And that is something that we're concerned about. You'll see a little bit, but by and large, the chair performed quite well. So we have to do something. There are many agencies in this country that allow people to ride their buses unsecured. And they're the same agencies that have called and asked for video footage, too. So we have lots of it to lend. The other one that we're seeing is people looking at rear-facing securement. There's a few issues where we haven't done a very good job, and that is the aisle restraint. It needs to be restrained on three sides. The way that that is configured still needs quite a bit of engineering work as well. So there's still some things we need to do. We need to refine how we approach securement in light of the fact that we're dealing with actually quite low accelerations. We need to do something about incidental motion, and for high-speed securement we need to look at the allowance that is allowed for mobility aids. Again, even on transit buses, the real estate is important and it's quite expensive. And typically with ADA, if you have a short space, you're going to increase the dwell time and the amount of time it takes that person to get into the securement station. This is actually in Oakland, California, and you can see they don't have any side restraint. And we're very concerned, well, they are too, about that from a safety perspective. But we're also working with the Access Board on redefining what we currently have for the ADA and for the space, because if we can make it longer, it will speed up the loading process as well. So there's still some unanswered questions, but fundamentally, I'd love to go on record and say I think rear-facing has a lot of potential, particularly for letting people be much more independent in their travel. But there's a few things that still need to be addressed, and that has to do with some sort of motion limiting if the person isn't able to hold on themselves. And also we need to make sure that we have adequate maneuver space on the vehicle itself. And this is very timely because a number of new BRT vehicles are being procured and specified as we speak. Question?
So that included then speeds, freeway speeds, because
yes.
Some buses that do, okay.
Yes. And in Canada it would be 60 miles an hour. Yeah, the drivers had a lot of fun. Yes, sir.
I'm assuming that these bus companies don't want to let you actually crash a whole bunch of their buses, but it seems like crashes would create much hierarchies and that you want to ensure that the passengers are safe when a bus crashes. Is there a crash data that's been done without wheelchairs in there that they already know what the D levels are for that type of stuff?
Yeah, we crashed buses. I just didn't bring those in this presentation. They crashed 3 buses and 6 vehicles, and they're still running the math on the analysis. We've had 2 different results, but typically we're around 6 Gs. Okay, so it's still pretty low. Even that was a peak, but they're still running the numbers on the crash data that was done, and that was done up in Canada. And I thought I had thrown that in there. I have another presentation that's not here, unfortunately. But I can come back and show you. That was the real boy stuff, you know, crashing stuff. Yes?
I'm not.
So I find it really difficult to sort of understand what, like, 2 feet disabled. In terms of the airport, are folks that are blind or deaf that really sort of can't hear one of the visual or audio aids in terms of PHing, things like that, are they really tuned in some of the new technologies for receiving that information?
The answer is some are and some aren't. It depends primarily on how independent the person is who travels. I know some blind people who are exceedingly independent. They have a lot of the latest technologies. They have service animals. They're very independent, and they have technologies. There are other people, for one reason or the other, who do not. And so there's huge variation. I myself am hard of hearing. I use assisted listening devices. And I'm getting better at checking the signs, because I have missed a number of airplanes, and it drives my husband nuts. And he says, all you have to do is just go up and check. And, you know, I do check, and then they'll change it. And any of you ever fly out of Washington National, and you fly Northwest, they have this pod, and they have like 4 gates. Well, they never tell you which gate, and they'll change them on you, and what's posted isn't what's real, and circumstances like that. So it's just a frustrating area. But there are other airlines that really are trying very hard in the passenger information displays. You'll also notice in this country huge variation in technology and investment in that technology that's at the gate. Some airlines have put a lot of funds into that, and others are just sort of a manual system with little cards and things. Yes, sir.
So is travel with disabilities becoming more of an issue because of the baby boomers are getting older, or is it because the numbers of people with disabilities are increasing?
It could be that. I think it's a matter of our world is becoming more accessible, and people with disabilities in general are becoming more self-empowered and generally demanding the same rights and freedoms that everybody else has. It's interesting, though, when you travel to other cultures and you work in other countries where they say, oh, we don't have a problem with people with disabilities because they never leave the house. And that's certainly true, but we'll see all over the world, we see those barriers and walls coming down, and people want to have the same rights and freedoms as everybody else. Yes?
Yeah, how did you define disability in this process? I mean, you talked about people getting bigger, you know, and heavier, and then also people who are confined to, for example, a wheelchair. So there has to be a difference.
We actually, on the survey, use the Bureau of Labor Statistics definition of disability. You have to be very exacting on our survey for, is a person disabled or is a person not? So in our survey, we use a very rigorously defined definition of disability. What we're seeing in the air, let's talk about the air travel world, because it's quite a lot different than Amtrak and over-the-road coaches. And in an air travel, weight is everything. And you've probably heard this in general, but the fuel costs are proportional to the weight of that aircraft. Okay? And one of the things you might think about, and we thought about in terms of the Air Carrier Access Act and airlines and operators in general, would be perhaps what we need to do is we give everybody a weight allowance. This is what happened when aviation in its infancy. You had a weight allowance. And in the early days, they weighed you before you got on an aircraft. Some of you who are a little bit older might remember those days. That you were weighed and your luggage was weighed, and they knew where the weight was on that aircraft. Well, planes have become a little more efficient. We don't do that, but we're starting to think maybe we need to go back there. So if you're a featherweight, you can take all sorts of luggage. And if you're not, you may have to pay a penalty because you are imposing an extra burden on that airline. Now, we're not there legally yet, but people are starting to look at that. In the Air Carrier Access Act, the revisions that are on the street right now, there is some small print that looks like if you occupy more than one seat, you should pay for that. Doesn't it seem fair? And it's interesting with our center, even though it's mainly focused on people with disabilities, that the number of complaints that come through to our website about obesity are enormous. And in some ways I'm starting to think, it's not, there was legal action, it is not defined as a disability. Obesity is not. But I think some people sometimes are starting to think maybe it should be. So, but also to be fair, in the disabled population in general, you will see a prevalence of obesity. And that's why we are so challenged in the design of a lavatory, an accessible lavatory. Robert.
A question coming in from the web viewing world. You mentioned the issue of why people don't travel, people with disabilities, and have you found what some of those reasons are?
No, we haven't conducted the survey yet. That was easy, but we hope to. Yes.
What about issues of time? Like the amount of time it takes on the exclusive versus inclusive type facilities?
Oh, that's a really, really good question. So just sort of your gut reaction, which do you think would take more time, an exclusive system or an inclusive? Inclusive, exactly. Exactly, so there's huge time saving. There's also an issue of dignity. And that first one that I showed you, that exclusive system, that person is there. I flew through an airport that will remain nameless on the record. And we were all standing on the tarmac watching them load a person with disabilities in a most undignified manner. I was just about ready to go bananas. And they had taken so long to move this person from the end of the jetway because the elevator was back in the main terminal, so the person had to go back to the main terminal, take an elevator, take a bus, go around. And meanwhile, everybody else is just standing on the tarmac while they loaded this person. I thought this was just criminal, very undignified. I was really, really embarrassed. And it happens all the time, and that's just not acceptable. Yes?
But does that research you study that in your research at all?
It's an element. It's very much one of the requirements when we talk about boarding technologies. The time element is very important, very, very important. And also in the securement world, on the buses and that, the dwell time is a very important part of the securement equation. And that's why we're looking at innovative ways that people aren't just belted down, that they can get on and off independently, dignified, and very quickly. And that's why the size of the securement station becomes important.
It's not that. I just got confused about why it would take more time to have the inclusive thing set up once that you pull it away than have everyone the exclusive thing, use it, and then pull it away.
It's much faster to use an inclusive system.
Oh.
Yeah, the exclusive is not. And also, there's a lot of negatives to it.
Yeah, I was wondering, are there national standards for accessibility of buses used by public agencies?
There are national standards under the Americans with Disabilities Act for buildings, rights of way, and they're called ADAG, and they're under their final review process as we speak. There's the Air Carrier Access Act, which we work with, and there are no codes of practice, standards, or regulations with that particular act. So they tell you to have an accessible lavatory. There's no definition of what's an accessible lavatory. And that's the niche that we're trying to...
What about buses, though? Like transit buses?
Oh, absolutely. And there have been since 1991 fairly stringent requirements. The number of securement stations, the loads they have to stand. But we're saying to them, when they wrote those standards, they didn't take any consideration to the mass of the transit vehicle. It was one size fits all, but you know that a paratransit vehicle performs very differently from a light rail vehicle. And so we need to have the securement appropriate to the mass and the performance and operating characteristics of that vehicle. And that's what this work is designed to do. Yes, sir.
I was wondering if you looked at or if there's any kind of requirements when it seems like I've been on a lot of planes where they change flights at the last minute, and even as someone who's fast, or reasonably fast, I guess, it's really hard to make the flight. So I guess the question would be do airlines now have any responsibility to sort of check and see if there's anybody who has special needs to make sure they can make it, or is that any part of the solution?
They try. They try to do what they can. But you know, the air side, if you get thunderstorms in Chicago, there's a lot of things you can't control. And so they do the best they can under the operating characteristics. But for people with disabilities, it's a challenge. It took me 2 days to get home from D.C. the other day, and I thought, boy, it would be so hard if I was a person in a wheelchair. I had dehydrated myself for what would mean an 8-hour flight to only discover it was over 2 days, all those issues. One area I haven't addressed in the presentation today that we are trying to help with is that of people who use oxygen and ventilators. There's a whole number of issues associated with that type of needs that we're working in partnership with some other entities on. But that's also, it has medical implications. You know, if you're on a ventilator, you have a battery, you need to make sure your trip is only so long. Yes, you can have major issues. And there's some critical pieces on that. And by and large, there are some airlines that are just fabulous about working with them. And then there are others that really don't care. And when people go to our center's website, they'll see who our collaborators are. They'll also see who's not there. Just say that. Yes?
Is there a lot of partnership with the industry that's providing the assistive devices? Like in terms of wheelchair manufacturers, scooter manufacturers?
We've been trying for 20 years to get them to the table. They will tell you when you buy a device it's not transportable. There's a legal waiver on them. And there's a huge battle waging in Washington, D.C. right now under the Health and Human Services about the medical prescription for devices that they're for in-home use only. And you'll see some press on that over the next 3 weeks. There's a major meeting in D.C. this week coming up. There are a lot of human issues over some changes at the federal level in Medicare, Medicaid, and health devices. In the securement world, we have tried to get them to the table to realize that people with disabilities have a life. And they just are not confined to an institution or their home, and that people need to get on to reality. On the other hand, in the other industries that we work with, which is the aviation industry, to me it is just amazing the amount of passion that we encounter of people wanting to do the right thing and working with us. It's sometimes I get overwhelmed with people, and you know, when you go into these large entities, there's thousands and thousands of employees. They work beside a person with a disability, or they have a family member who is disabled and they want to travel. And that sort of passion translates into their jobs. And so we are hitting absolutely no resistance, really, on the work that we're doing. In fact, the support's amazing, and it comes from pretty unexpected places. So. Yes?
Are there challenges or issues for service dogs in flight? What's the policy on?
Oh, there are some, you know, I don't know the details of the policies, and airlines have their own procedures, but service animals do accompany the person. They're usually, person's located in the bulkhead and the dog is positioned there. I don't know about the fees. Sometimes they charge a fee for that, but generally service animals accepted, and usually they're the best behaved passengers on the aircraft. Yes?
It looks like you looked into buses, not rail, in your analysis of wheelchair and disability accessibility. Most buses have a lift. It seems more like the exclusive entry for...
Actually, that's not true. Most buses now are becoming low floor. All new procurements are low floor buses, and there's a ramp, which makes it easier for everybody. The old technology, or lift, or a kneeling bus, and those actually have virtue in areas where you have no sidewalk. A lift-equipped bus is more accessible than a low floor bus because you can get the person right down. But generally, most new bus procurements in the United States or North America and Europe are all low-floor bus vehicles. So the days of the lift are quite numbered. We do work, just to clarify, we do work with Amtrak, and we work with the over-the-road coach industry. And those, Amtrak uses a combination of onboard and wayside lifts, and the over-the-road coach industry generally has an onboard lifts the vehicle up, the mobility aid. And if you ever ride one, ride it facing towards the vehicle and not out, because it's really scary. I think I've run out of time, have I not?
Before we thank our speaker, I'd just like to thank all of you for attending and remind you that next week another OSU visitor, Gail Achterman, who's the director of the Institute for
fabulous.
Natural Resources at OSU, but also the member of the Oregon Transportation Commission, and she's going to be speaking about the update to the Oregon Transportation Plan that they're currently buried in. So bring some good questions for Gail, and so let's thank Professor Hunter-Zaworski.
Thank you. Well, I'm sorry I'm in D.C. next week because Gail Achterman is fabulous. I'll just put it to my home. I can watch her presentation on the web. She's really a great speaker. And we both drive Priuses, so yeah.